Hello, Poe. We're going to talk about, can unification give us anti-gravity? This is Antigravity Explained. I'm Professor K here. We're going to move right along with a brief history of what we do know in particle physics, gravity, chemistry, and material sciences. Let's start with light. What we know is that photons are virtual particles measured by their frequency. I'm going to use this board as some drawing and reference. So let's just draw photon. And this is going to be represented as such. Is it a particle here, or is it a wave? Again, virtual. It's not known at this point whether or not it is a particle or a wave or both. But the fact that that question was ever even asked was certainly great. And we need to ask questions like this. The why, the how, and not just shut down an avenue just because we figure, oh, it's beyond our ability or realm to know these answers. Now, the photon, it can only be observed straight on in its path. A photon whizzes by you like this, you're not going to see any light. It has to come directly into your eye for you to be able to sense a photon. It's only straight on that we can observe this, frequency. Now, there's enough other information, videos, all sorts of stuff out there explaining a lot of this stuff. So look into that if you will. Again, this is anti-gravity, which is going to get crazy at some point. So we'll see. Now, next, let's just briefly discuss what is gravity. Well, it's an expressed relationship between two objects, two or more objects. I'm going to just draw a brief representation here. So you have object one. We'll just write object one. It's not a very good one. And then object two. And it's the force between them. Let's see. And it's expressed as such, but what seems to be the consensus is that these objects, when you have an object like this, its mass warps. It's pretty a term that's not always clear to people what that really means, but we'll come back to that. As we feel it, gravity, pulling us down, is really a very emergent property of this warping. People have asked, well, is there a force-carrying particle? Is there this infamous graviton? How would that work? Again, more great questions. And we need to keep asking questions like this, as we move along. But that's light, energy, gravitational force. We're just going to keep going here with the. Okay, so we have dark matter. What is it? What is dark matter? Is it a force? Well, it's kind of, again, a representation, but it's kind of what's holding galaxies together. I'm going to try to draw what I would call a swirling galaxy here. You know, these are little stars and planets. These are this is my representation of galaxies here. But what you have is you have this dark matter, which we don't know what dark matter is, but it seems that we have a little bit extra a force due to this dark matter that's holding these galaxies together. And then there's another unknown out there, and that's dark energy. Again, this is observed with the aspect that there's something pushing these galaxies apart. This is gravity. So dark energy is a force pushing galaxies apart, and then dark matter is what's kind of holding them together, keeping them from their rotational velocities being able to fling everything out into away, the stars, the planets, and so on. And it's unknown, what this stuff is, hence the term dark. Someday when people figure out what that is, it'll certainly be an exciting day. But yeah, there's lots of unknowns out there. Next, we're going to talk briefly about the material sciences and chemistry. So there's a lot of unknowns. I'm just going to write here. Substance A plus substance B gives us what? And that's the unknown when it comes to these material sciences. What happens when we combine one substance with another? What are the new physical properties? Is it something that, does this new substance, does it stretch? Does it glow in the dark? Is it some type of impenetrable material? It just goes on, this endless, study of, things out there. New stuff could be to be discovered. Could we mix something here and have something now that levitates or becomes invisible? These things, this information, when we discover something new with materials and stuff, it's a lot of information that has to just kind of get cataloged or put into databases. So this way, eventually, when we get all this information, we can do things like, decode DNA. We just need more and more information out there to help us do stuff like that. And then finally, at the quantum level, what we have here are we have nucleus here will represent with a couple protons and neutrons, and then we'll kind of draw an electron zooming around. We'll just give it some direction there. What's happening in this down in here? We have the electromagnetic force, between the electron and the protons in the nucleus here, and then you have the strong and weak nuclear forces. I'm just going to represent electromagnetism with EM for now. So, why? Why does this stuff happen? Again, those are the questions. Those are the big questions about what we need to ask. What creates this interlocking within this atomic structure? What is really happening there? And if you want to learn more about these forces, again, plenty of information out there. Go ahead and look up any of this stuff here. So when we learn about all this information, it answers a lot of questions that we've had, and helps us to learn and grow. But what happens is it also tends to create a whole new list of questions, opening a door to just a whole new world for us. Some fun questions people like to ask is, well, now that we know this or whatever, what about time travel? Is that possible? Can you use wormholes, anti-gravity, invisibility, things like that. But also deeper questions like, well, what caused the Big Bang? And here's a question. Could you take a teaspoon of what is the neutron-dense plasma of a neutron star, just a small amount, and then somehow use that as a fuel source, in the future? Or can you genetically alter a person's DNA, to have them grow a pair of wings and fly? These are crazy sounding, a little far out there, but the more we learn, the more we find that some things that once seemed crazy start to seem more and more plausible. Giordano Bruno, I think it was in the 16th century. He was a guy that was killed at his time, for saying that the Earth was round. Some people at that time just found that impossible to imagine. Crazy nonsense. So in our advancements, we learn new things. Like I say, it's about asking the questions, as silly as they might sound, and then pursuing that and trying to figure that out. Trying to figure out, is this something? A big question is, how can we use this? How can we use what we've learned to help us? And there's been a question about, can you get more energy out of something than what you put in? There's a project going on right now, and it's called ITER, I call it. I'm not sure if there's a pronunciation to that. I suppose the Latin pronunciation would be ITER, which I think means like the way. But anyway, ITER, it stands for the International Thermonuclear Experimental Reactor. And what that is it's a fusion reactor, and it uses what's called a tokamak design. And it's kind of like the opposite of what we currently are using for energy, which is nuclear energy, which is fission, nuclear fission reactors. If this works, this would change the world. It's a way to generate clean and abundant, and when I say abundant, I mean nearly limitless energy. Now, not just this one reactor. You'd have to set up the infrastructure, but basically, if you get so much more energy out of something than what you are kind of putting into it, that's going to help you to, you have all this extra energy. Oh, now what? Well, let's build some more reactors, and that way then we can, power the planet, hopefully. But my prediction on that is we probably, it's scheduled, I think, to be completed in late 2025, but my prediction is we probably won't know until like 2029. And that's simply because history has shown us that political, religious, economical influences have only ever hindered, the advancement of science and technology. And history has also shown us that with anything new, there's always hiccups. Always. There are always, little things to work out, little kinks along the way. I pray that this ITER experiment works. It would just be astonishing. It would be great. So I'm going to explain a theoretical aspect to some of these unknowns out there by asking some questions and proposing some answers to them as well. So the first question here, I'm going to come back to this. What is a photon? Well, we kind of answered that. It's what you might call a quantized packet of energy. And the question that I want to propose is that, okay, if you have your photon, which, is this particle, and that, I guess, has an oscillation to it, or a frequency. Well, what if that particle is still moving straight forward, but no longer is oscillating, or has an oscillation or a frequency of 0? There's no specific moment, but yet, at that point, or the moment is so far spaced out in between each of these moments that the time is seemingly forever. Does it exist? If you have a photon at 0 frequency, do you have a photon? Do you even have anything? And how would you know? You can't detect that, but it's just kind of a question to propose right now. If you say this value here is something like 10 to the minus whatever, we'll just say 20, you have such a low energy, and virtually, again, it's kind of like trying to measure gravity at the quantum realm. So we'll come back to that. Let's just discuss gravity for a little bit. Now, gravity is the most powerful of all the forces in the universe. But when you get down to this atomic level, gravity, this immensely powerful force, just disappears. It drops away. It's like it's not even there. Why is that? When you get up to the size of galaxies and stuff, gravity overpowers everything. And it takes over in such a way that you form these anomalies called black holes. Again, plenty of information out there on black holes. If you'd like to learn more about black holes, have at it. But a black hole, just a reference here, actually looks a bit more like this. Some of the images you might see out there might look drawings. You'll see drawings or pictures that look like this as a representation of a black hole, but a black hole is really a sphere, and what this is expressing is just showing you kind of how it warps or bends in the space-time. It's how it's folding it down to this singularity point. But you'd have to just kind of imagine this as this here, this flat plane I have up here, kind of curving all the way around. Every part is like being pulled into the center, and as this curves all around, that's your outer edge there on your sphere. So, gravity, most powerful, can form these anomalies, just shuts down everything. I mean, light, our energy here, or the electromagnetic forces, the nuclear forces, they just get ripped apart by gravity when gravity gets so high. And if all of space, space-time, were completely empty, there would be no gravity, because you need something in it. Like we said, gravity is this emergent force. It's kind of like once you have something, then you have gravity. It'd be like once you've decided which way you want to call up, well, by default, then you know which way is down. It's kind of like just this, effect. But when you try to this most powerful force ever, you can see it shaping the entire universe. But when you try to zoom in and you look at this and you try to study what's going on with gravity at this small scale, it's like, well, where is it? I mean, we could see it out there, the effects on the planets, stars, galaxies, and then it just disappears. And this representation of space-time folding, what is space-time? Is it this fabric? Is there a particle that makes up space-time that we just haven't figured out yet? Maybe like a dark matter particle that's what space-time is. Maybe the infamous graviton. Again, this is unknown, but I like to think there is that there's some particle out there, and I'll explain why I think that is. But we'll ask one other question here for a second, and we'll come back to this again, and that is, why is it that when you look at these relationships of things, the electron or the proton, why is it that these perpetually move? They just continue to go on forever. Why is that? Why do they live forever? Why do protons live forever? It's like they don't lose their energy. And people have been questioning stuff like this. And when we look at it, we can observe and say, well, it can. You stick something in this path and you can maybe slow down this galaxy, or you stick something in here and it can soak up the energy of this, electron or what have you. But untouched, these things will just keep going. It's just keep going. And what I think is happening here is, again, I think this is just kind of like another emergent force, if you will. Just an emergent property of how, our space-time works. You put something in it, it's just going to kind of keep going. Right now, I'm going to pause for just a second, actually. I'd like to take a brief moment and just say that we owe this huge debt of gratitude to so many people and scientists out there for the advancements of our technology, leading to medical cures and better health and longevity, as well as all the wonderful gadgets and gizmos and everything we have out there. Throughout history, and even now, there has likely been many people who held these answers, in their minds, like the cure for cancer. But unfortunately, like Giordano Bruno, were, had their existence denied or suffered in a way that extinguished, what they could have offered. So just imagine where we could be if we could just have been much nicer to each other. And that's just it. Just, be nicer to each other. share with those who need it. Be tolerant. Learn to compromise. And don't always just think or care for only yourself. We all need to be better at just trying to work together. Thank you. Okay, so going back, this is where this is going to get crazy and this is going to get a little intense. So here's the theory. Why do electrons eternally spin? Why does the combination of quarks, say, that make up the proton, live forever? Is there a graviton? So imagine, if you will, that space is not empty, that the universe, or space-time as we know it, is made of an infinitely expanding foam. A very weak particulate, but where the space is so small that within the tiniest point, just the tiniest point ever that you can imagine, there can exist an almost infinite or a countless amount of these space-time particles. And that limit would then be defined by going back to this here, black holes. Okay, so that would give us kind of an answer as to why then black holes, which are larger in size, have a lower density. That maybe there's a limit out there. And that theory would go on like this. And I'm going to give an analogy. It's gonna be weird, but it's just, bear with me. So space-time would be this foam, a weak, but like soap bubbles. If you have all these soap bubbles and you compress them down into a solid bar of soap, then you have something. You have a mass, right? A small block of potential bubbles. Okay. Now, what does this have to do with the electron and the perpetual state of motion? Well, think of the electron like a highly compact version of trillions and trillions of these, photons with a frequency of nearly zero, bunched up together. But because there are just so many of these at this low energy, these bubbles, eventually the number of them equate to something of value. And now that piece of soap, that bar of soap that you have, bounces around and moves through the rest of the soapy foam bubbles. And those bubbles around it then shift and pop, and new bubbles are immediately formed and flow in to fill in those voids. So you'd have this ether, this space-time particulate. Of course, this is all conjecture and may seem very wild, but we don't know. Is there a structure? Is there something to space-time? But what I'm suggesting here is that there might be a flow. You have your electron zooms around and it's popping these bubbles, and then so what happens is way out here, you begin this chain reaction, and these bubbles start flowing in and shifting and forming, and you create a more dynamic form of space-time. And this minute energy of these, and keep in mind, these are moving at the speed of light, these space-time bubbles. This minute, ever so minute, energy is basically transferred back into that soap. The bubble pops, but there's nothing to it. It doesn't really affect the soap very much, but enough of it happening. And what happens is that tiny minute energy it took to pop the bubble, the new ones reformed, you replace that energy. And then that helps that bar of soap to just kind of keep going around again. One more time, keep going. And there's no gain of energy to that bar of soap, but more importantly, there's no loss. And that's why you end up with this perpetually moving objects. It's this frictionless surface. Now, things can flow through this ether, but more importantly, what's really happening is this ether is flowing through everything. Passing right through every particulate down to, whatever the quark actually is, passing right through it. Maybe it's a carrier of the quark's energy, and that little foam carrier is what's helping to create this interlocking, and so on. Again, I know this sounds crazy, but this frictionless surface, at this small scale, this motion is typically negligible. But what happens is when you have this electron and you have ones filling in, at the small scale, it's like, it pops a few. And so you have a small radius. And so broadening out here, one part out here and one part out here, not that big. You don't notice it. It's negligible. But you have a mass, you have trillions and trillions of these electrons. And now what happens is this radius, more and more things, you have a convergence here. And you have this inward advancing flow. And that's how I believe these gravitons would be working. Gravity would just be kind of like googles and googles of gravitons. This vast number eventually adds up to this force when you have so many of these. But rather than gravity just warping space-time, it just might be this current, this dynamic movement within it. And again, these particles, space-time particles, they only ever move at the speed of light. And so the number of these interactions would equate to, of these particles flowing would equate to the number of particles you have. And that's how gravity is proportional to mass. As the particles move through, they create the voids, the flow, the more particles, the more flow, and so on. And so this would be saying that, gravity, we've referred to it in the past as this pull, and people have said, well, maybe it's a push. It would be, a current, and we are all just caught in this current. I compare it kind of like learning about like nauticals, to remain stationary, you still have to put forth some amount of energy to counter the current that is acting upon you. Now, if this was the case, this could actually help to explain things like dark matter. I mean, if there's a dynamic convergence out there, maybe there's something broader than what was anticipated, that's kind of holding these galaxies. And then also, if there is this dynamic foam, then what would happen is, as these things got so anyway, moving on, a black hole event horizon, which would be this surface here, would basically be the maximum number of these foam particles. Well, I don't know about the maximum number, but it would be, the minimum number needed to stop a photon. In other words, all of the space around something is moving in, not just the ones needed to replace the voids, but you have so many voids that it's all moving. And once all this space-time is moving, this dynamic flow, it is warping. It's curving everything. It's pulling everything in, and even the photon can't, get past that. But it would also explain why that there's kind of virtually no difference. Say if you were hanging out here on this edge, time would slow down immensely for you. You wouldn't notice it, but an outside observer, you would live forever to an outside observer. But that effect of time slowing down, that's why virtually, if you're hanging out here versus if you're just traveling, near the speed of light through this foam, how it doesn't make a difference, in relationship to time. So in other words, if the most particles that are in front of you are, their energy at the speed of light, then all of them are moving through you, what's the difference than sitting right here? Because you have all these particles doing the same thing. And that energy is what slows down your time, your clock, if you will. And again, you can't really do that. You can't really hang out here because you would get sucked in by the gravity. But it's this is theoretical. If you could hang out there, that's what you would experience as time slowing down. But the amount of energy that you would need to hang out there to work against the gravity pulling you in, you'd have to use a lot of energy. And similarly, to get going near the speed of light through space, you'd have to use a lot of energy. At a certain point, the amount of energy input would skyrocket because the amount of energy that's coming against you. But that would also help to explain things like this, what's called a pancaking effect, if you will. So now, anti-gravity. Let's, if we've defined gravity as this foam, let's try anti-gravity here. We're gonna draw a picture here of a reaction, and we're gonna put some lines on here just to explain what could be happening here. So as there are certain interactions of mass, now much like the positron and the electron here, they can collide to produce some very high energy photons. What happens is there could be, there just might be a certain interaction here if you have a substance. And what happens is here in the decay or just an emittance of nearly zero energy particles. And I say nearly zero because they would have to basically equal our gravitons here that make up our space foam. But if you have an interaction where this is being emitted, these nearly zero low energy photons, the equal amount of energy. So if this would be this nearly zero rather than this gamma ray, and again, at these high energies, the photon is going to be more like a particle, and at the low energies, at this nearly zero, it's going to behave more like a wave. But then you would need so many more photons. You would need trillions and trillions and trillions more photons of this low energy just equal to one of this high energy. But you could basically, in a sense, have this huge release of these particles. And that's kind of what would be happening. These gravitons or zero energy photons, if you will, they would be diverging out away from a substance, and that would give us this anti-gravity. However, if there is anti-gravity, this converging action, and if this is how it works, would be acting more like what's called a white hole, which is the opposite. This is pulling everything in. It would be trying to push stuff out. And there would be a whole new set of rules around how this works. Light, can't escape a black hole, but similarly, a white hole, light would just kind of bend around. It can't really get in there. So that substance, whatever it might be that you find that has this anti-graviton whatever properties, it might just be invisible to you. You might not know it's there, and it would be difficult to study. And within that white hole, where everything is moving out, you'd have different laws well, it wouldn't be different laws. You'd have this would exist outside of our laws of physics. It would be in its own little contained pocket universe, because everything in our universe is existing within this foam, and this foam is kind of what sets the rules for all of us. So if you have something that's generating out its own foam, what's going on in there will likely be the same rules that we have, but it would take this object spewing out, and within it you might have its own foam, but then outside of it, it's generating this flow of space-time, and that's how anti-gravity would work. And we would have no way of detecting this. So if you have, I'm going to draw, this is a hypothetical spaceship here. If you have a spaceship rocket, right? Your fuel source, it will be this matter, whatever it might be, that is emitting gravitons or space-time particles away. Here's the center of its mass, and equally all out in the directions. This rocket shape might not do you any good, because there's no reason to have that type of structure when you have something that would have these. But the point is if you were sitting here, here's you sitting in your spaceship. If you were sitting there, you would be sitting against the wall, and that gravity would hold you, or the space-time particles flowing out from your mystery substance would be kind of acting as your gravity within the spaceship, and would keep you against your seat inside there. And you wouldn't need that much more, because these particles flowing out would basically act as this wave that you could ride, much like a surfboard. It would just carry you in the direction that you need to go. You would want to control that by basically having something where its center of mass is shifted over here, because then as you rotate this, that would give you the directional that you would need for your anti-gravity rocket, if you will. But again, when you're inside there, there might be some other low energy light being emitted, so you might be able to see this material. But it's likely that if you have this flow of space-time particles, this would be invisible to you. It would kind of exist in its own little separate pocket, like I say, universe. It's not really, it's It's just that you have a substance that's just pushing out so much that, light, when it comes toward it, you have this flow coming out. Light, when it's going toward a black hole, might get sucked in, whereas, inadvertently, it would just kind of get pushed away and just kind of bend around it. So now, if you think that you can use, these gamma ray energy, if you will, to create lift, then why not use that same amount of energy, but just in radio waves? It'd be a lot more photons, but that's kind of what might be happening there, and that's kind of how it works. So the fabric, quote unquote, I will say, of this space-time being stretched or warped instead, it would basically be this dynamic particulate ether, and that would be what gives us this anti-gravity. This would also help to explain, like wave propagation. A particle or wave. What's the wave? What's the medium the wave is being carried through? Things like quark pair interlocking. And a big question is if the fabric was stationary. Let's try to draw some fabric here. If your space-time fabric is stretching, here's your mass causing it to stretch. What creates the movement? If space-time is stretching, why does something necessarily move in one direction? Again, I mean, this is what is thought is happening, the stretching, and we know there's movement due to this warping. But why? Why is there movement? That can't really be explained, and this would explain why there's the movement. So hopefully this has been somewhat helpful. But that's it. That's the anti-gravity.